Hey YouTube, what's up? This is Link. Welcome back to another episode of coding session. So the problem of the week that I got from Leetcode is the first bad version. It is a easy difficulty problem. So we'll start out by reading the actual problem itself. So you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions, 1, 2, all the way to n, and you want to find out the first bad one, which causes all the following ones to be bad. So you're given an API, which is bool is bad version, takes in a integer parameter, which is version, which will return whether that version is bad. That specified version you pass through the method is bad. Implement a function to find the first bad version. So what comes to my mind first is we can just do a linear search. So int I is equal to, for int I is equal to 0, I is less than n, I plus plus. And then we could do if is bad version, which is I, then that current I is going to inevitably be the bad version. If not, you just simply want to return n, which works. But what if we could just make this a little bit more interesting? So we can use a common algorithm that we learn in our data structure classes, which is the binary search. The binary search pretty much consists of repeatedly dividing the search interval in half. There is a left, a mid, and a high pointer. So if the value of the search key is less than the item in the middle interval, we'll narrow the interval to the lower half. Otherwise, we narrow it to the upper half. So if we look at some code here, this is in Java. At the beginning of the while loop, we determine our new mid, and of course, if the current middle we're on is equal to that search key, we found it, just return it. However, if the current middle we're on is less than what we're searching for, such as we're on 2, let's just say that element's 2 and we're searching for 10, which this example seems to be searching for 10, we want to raise the left or increase the left pointer. So we're going to ignore more of the left half. And if not, let's say if we're on 12 and we're looking for 10, if the x, if the array m, which is the array m, let's just say there's like a 12 here, for example. I don't know if you guys can see my cursor. Let's say there's a 12, it's 10, 12, and 40. If that 12 is actually greater than 10, then we're going to move the right pointer a little bit lower, ignore the rest of the right half. That's just an example. Because if 12 is greater than 10, which it obviously is, we're going to want to go ahead and start ignoring more of the right half. So that's essentially how the binary search algorithm works. You have 3 pointers, left, mid, and right, where you are repeatedly dividing the search interval in half until you find what you're looking for. So we can take advantage of that. I actually have another graphic to show that kind of explains this a bit better. So scenario 2 is kind of what we're looking at here, and of course, if there is, so if you're passing in the mid to is bad version, and of course it's good, obviously it returns false. But we look at scenario 2, if we pass in mid and it is actually a bad version, we want to go ahead and move or ignore the rest of the right half. So right is going to move down, right will be the new right is going to be that current mid, which will be right here. But if it isn't bad, then you want to start ignoring the left half and start increasing the left. Now, our new interval is going to be, instead of 1 through 9, it's going to be 1 through 5, and once the while loop executes again, our new mid is actually be on 3, which is a good version. So now we're going to start moving the left pointer up, and since we're the mid at this point is a good version, is a good version, it's inevitably going to be continue to be a good version once it hits a good version, and eventually left is going to pass the mid, and if left instead of less than right is less than the right, is actually greater than the right, inevitably the left is going to be the first bad version. This will make a little bit more sense once I actually implement the algorithm. So int left started at 1, and int right is going to be n. So while the left is less than the right, define our new mid here, which is int mid is equal to left plus right minus left divided by 2. That's how you get the mid. So if is bad version of mid, the new right is going to be the mid. We're going to start ignoring the right half. If not, then we're going to start ignoring the left half, and instead of obviously right going down, left is going to start going up, going the left half that is irrelevant to our search interval, because that's not where it's going to be at. And of course, inevitably, we return left. It's going to be the actual bad version, which is what I was going through before with this graphic here. So let's see if this works. All right, it works. So let's see if it passes all the test cases. And there we go. We implemented, not only did we implement the brute force way or the linear search way, but we went ahead, made things a little bit more interesting, and implemented a binary search for this problem, which is first bad version on Leetcode. So this was a problem of the week I had. I got the Leetcode Weekly Digest email. That was one of the problems. I guess I haven't done yet, so it picked it as a problem of the week for me. Binary search, it can be confusing at first, but it's after you start looking at it more and looking at more examples, it starts to make sense, and it's very intuitive. That's how I would describe it. So that is binary search and the first bad version problem on Leetcode. Thank you guys for watching, and have a good day.